Hello everyone, welcome back, and let's proceed with our module 3, that is ensuring that routes are reachable. So we're going to configure static routes from enterprise to the one, and on the one we are going to employ OSPF and BGP, and also we are going to employ IS and BGP, and on data center we are going to deploy OSPF. So let's see. You have been provided with some little help here. So routes from the traffic from the enterprise to the one. We're supposed to configure static route from firewall 1 towards the PE1 router. So enterprise to 1, firewall 1 and firewall 2 on the enterprise internet use static default route to divert traffic destined for the 1. So like that is the 0.0.0, divert the traffic destined to 1, that is from the intranet. Then from 1 to enterprise intranet, the internet router on the 1 advertises the internet route this 16.16.16 using extended border gateway router. This internet router is going to use extended gateway to advertise a network of 16.16, that is for the loopback. PE on the 1 uses static route 192.168.0 to divert WLAN return traffic to the enterprise. So this one is going to advertise this one where network of 192.168.2, where its next stop will be on firewall 1, interface on firewall 1 and firewall 2, and web server service route diagram. So that is from the now enterprise to the data center. Firewall 1 and firewall 2 on the enterprise intranet use static default route of this one, that is for the public, to divert traffic destined to the web server. So you see here static default route of 100.1.1. And step 2, firewall 3 in the data center uses BGP to advertise the route 101, that is forward. It uses the BGP to advertise this route to the web server public address to the VPN instance of PE2 in the 1. PE2 advertises the route this one to the P through MPBGP, that is multi-protocol interior border gateway protocol. P reflects the route of P1 so that traffic destined to the web server can be transmitted to the data center through the 1. Firewall 3 diverts traffic to the web server through OSPF, and route is 172.16.1.0. So that is what we are going to do. That is, you see here, firewall 3 advertise OSPF default route of 00, then also it advertised the route of 172.1 to the web server. So that is now from data center enterprise to internet, firewall 3 in the data center advertised the OSPF, like I've said, the default route, and the static route of 192 is configured on the VPN instance of PE1. So VPN instance of PE1, we're going to configure static route of 192.168.0.0 to direct return traffic from the web server to the enterprise internet. The route is advertised to the VPN instance PE through IBGP for enterprise return traffic. So in this part 6, we are going to implement it on MPLS VPN, and also .2 here, part 2 here, we're going to place on MPLS VPN. But on this lab, we are going to configure static routes and also the dynamic routes, that is the IBGP and BGP. So let's see now the requirement. Okay, task 1, configure static route on firewall 1 and firewall 2 to divert the traffic destined to the internet and the traffic destined to web server in the data center to the 1. The main interface of PE1 is used to receive, so you should be very keen here. The main interface of PE1 is used to receive traffic destined to the internet. Then its sub-interface is used to receive traffic destined to the web server. On PE1, configure static route to return traffic destined to the WLAN client, and one route points to firewall 1 and the other one points to firewall to thereby load balancing. So that is what we are going to configure. So we know very well that when we say that the main interface are used on PE1 are used to destine traffic to the internet, we know sub-interface traffic gig 101.1, the network will be IP address is 10.2.2.2, and for gig 103.1 will be 10.3.2.2. That one is for the sub interface. That the main interface IP address will be 10.2.2.1.2. So meaning that when we need to configure the routes, we need to consider very well those interfaces. That one, as you see there. Note, the main interface of PE1 is used to receive traffic destined to the internet. So meaning that we are going to configure the next hop for the main interface, that is gig 101, gig 0/0/1, that is on router PE1. But now to receive the to receive traffic destined for the web, you're going to use now the sub interfaces. So that is the sub interface, that is gig 101.1 and gig 101.2. Clear? Now let's embark on our lab. So we must ensure that we see this directive from, these are the things that are going to assist us configure those routes. So come to firewall 1, admin Huawei 123. So we are going to start with firewall 1 main interface. So we are told to advertise the default route. So IP route static, here the default route will be 0.0.0.0 with a mask of 0, because they said firewall 3, because they say PE3 will receive the root with the main interface. So we are going to configure 10.2.1.2. That one will be the next step. That is the interface. This, you see this interface here on PE1. It will receive this default route. So then the next we are going to configure, like the next is supposed to be the default route, that is 100.1.1, and it is going to be received with the sub interface. That the sub interface address we knew was 10.2.2.2. So IP route here, IP route static will be 100.1.1.1 with a mask of 32, and our IP address for that sub interface that will act as the next hop will be 10.2.2.2. So we are done with firewall 1. We are going to firewall 2, configure the routes. So admin Huawei at 123. So we are going to configure the IP routes that reflect the main interface that is going to be received by the main interface. So IP route 0.0.0.0, the mask of 0. Now the next hop will be 10.3.1.2, that is for the main interface gig 0/0/3. Then we configure the default route that is going to advertise the public network. So IP route static here will be 100.1.1.1. Now /32, we are supposed to use the sub interface that is on being the next hop of 1.3.2.2. So we are done with the static route on firewall 1 and firewall 2. Then now we are going now to configure. From this diagram here, you see on this router, it's going to configure the routes towards the firewall that is directing the network of 192.168.2, and the next hop will be the interfaces of this firewall 1 and 2. So that is the route that is emerging from router PE1, that is the provider edge router 1. On PE1, configure static route for returning traffic destined to the WLAN client. So now, and the route should point on firewall 1 and the other one points on firewall 2, thereby load balancing. So firewall 1 and firewall 2 are going to act as their next hop for router number 1, the PE router. So we're going to configure IP route static here. We are going to point to the network of the WLAN, that is 1.2.0, the mask of 0, mask of 24, and it point to the next hop on the firewall 1, that is 10.2.1.1. That is interface on firewall 1. Then next, we are supposed to configure IP route static 192.168.2.0, but this one will now point to firewall 2, that is 10.3.1.1. Sorry, we have not given it a mask. /24. with that next hop. So the route to the firewalls have been configured. That is going to direct the traffic from the data center towards the enterprise WLAN. Next is now to configure firewall 3. So we've been told that firewall 3 is going to configure a static black hole route on firewall 3 to the public address of the web server, that is 100.1.1. Then also configure the default route to direct the web traffic into the data center. So IP route static here will be 100.1.1.1, the mask of 32. We've been told to configure the black hole, so we're going to tell it null 0. So that one we've configured a black hole route. Then the next one was to configure the static route, the default route from to direct the return traffic from the data center to the one. Now IP route static 0.0.0.0. Now with a mask of 0, the next hop will be the interface on router number 1. That will be 20.1.3.3.1. That one will be the next hop. So we are done with that. Let's save our configuration. Control save, say yes, and come and save on our device. So meaning that we implemented this part of static public network. We have configured everything here. Now we are proceeding to task number 7, having done task number 6. So on task number 7, we are going to configure the dynamic routing, that is the OSPF and ISIS. So what do we do here? Because now I think all these firewalls we have done with this. Control save, say yes. We want to shut this so that our network does not buffering. We are going to stop this firewall 1 and 2 because we won't need them in the configuring this other communication on this other network. So let's stop them and start the devices on the 1. We're going to start the device now so that we configure the ISIS and also the OSPF. After we start those one, you also need to start these other ones. Because that is where our main focus will be. The enterprise, we won't be interacting with the enterprise devices much, but we are going to interact mostly with the one and also the data center when we are going to configure this part of dynamic routing configuration for the public network. So we are on the public network. So task number 1 says deploy ISIS on 1 connecting PE1, P and PE2. Set the ISIS process ID to 1, ISIS area level to level 2, and the area ID should be 01. Then customize the system ID, enable ISIS on loopback 0 and gig 0/0/2 of PE1 loopback 0, gig 0/0/1 and gig 0/0/2 of P on router, as well as loopback 0 and gig 0/1 of PE2. So that one will be the first step. Then to complete the IS on the 1, to improve network security, configure MD5 authentication for LSPs, CSNPs, and PSNPs. Those are the ISIS packets, and authentication password should be ICT exam. So that one is for the ISIS. So that is what we are going to configure on the one, that is PE1. So let's begin with the ISIS configuration. So deploy ISIS on the 1 consisting of P1. So set the process ID of 1, level 2, ID of 01. We're going to customize, like, you know how to customize. I hope you guys know how to customize the system ID. So let's check the loopback IP. So interface loopback 0, this So this loopback 0 address will be 1.1.1. So to customize the system ID now will be 1.1.1.1. So we want to customize it system ID. So we add two zeros before every one. I mean two zeros so that it becomes a 3. Each octet has 3. So after you add two subsequent zeros, the next thing we are going to do is now divide this address into 3 parts. So when we divide it into 3 parts, we are going to move this decimal point to this point. So we're going to remove that decimal point and move it to where point 1 there, because we said we are going to divide into 3. There are 12. Now when you divide by 3, each will contain 4. So now this one now will be our system ID. So we know how to combine now. How do you consist of the system ID, the area ID, and also so area ID they said 0.1, then we add net at the end of it will be 0.0.0. So that one will be act as our network entity. So this one is what we are going to configure as network entity on router number 1. So we will just alternate where 1 is, we'll just give it 2. So for the customer system ID. So enter into that router number 1, quit. So ISIS process ID they said 1. So we enable ISIS level 2. You are supposed to enable ISIS level 2. And network entity here will be 01.0, that one 0.10.100.100.1.00. That one will be the network entity. After that, you are going to quit. We are supposed to enable it on loopback interface and also gig 102 that connects to PA provider router. So interface loopback 0, enable ISIS on interface, ISS enable 1. 1 is the ISIS process number. Then we are told to configure also the authentication. So tell it ISIS authentication here mode. They said use MD5. Then the password will be ICT exam. Quit and enter for gig 2. So interface gig 0/0/2. We are going to enable ISIS 1. Then the password for the interface will be the same, will be ICT exam. So having done that, we just quit and save your configuration. We move to router number 2. Router number 2, we are going to enable ISS on gig 1 and gig 2. So and also on the loopback interface. So here we say ISIS, we process ID of 1. Now ISIS here, this one will be level 2 router. Then network entity will be 01.0010, not 0020, because this one we are going to use the loopback which is 2.2.2. When we customize it, its system ID will be 00.20, 0.200, then 2.2.200, 2. Then our net will be 00. Then I enter interface loopback 0, ISIS enable 1, After you enable ISIS on that interface, we are going to now enter interface gig 0/0/1. Sorry, we have to give it authentication mode. After you give it the authentication is when they will be able to change the ISIS packet. So ISIS authentication mode MD5. So we said ICT exam. Then enter quit interface gig 0/0/1. Enable ISIS on that interface. Then authentication. Also enter gig 2. ISIS enable. IS authentication here will be ICT exam. So the interface keep on going on and up. So, but we'll be able to see them exchange state being established. So we've configured ISIS on that. Now we are on PE3. So that we don't inconvenience and to see it working, let's first stop some devices here to ensure that our network is stable. Now we are on PE3. PE3, so not PE3, PE2, that is the provider edge router number 2. So we are going to enable ISIS 1. So press ID of 1. Now net ISIS level will be level 2. Network entity here will be 01.0.0.0.3003.3003.00, and we quit and enter interface loopback 0 ISIS enable 1, then interface, the interface that connect to that provider router is interface gig 1. So interface gig 0/0/1. Sorry for the we've not configured the authentication mode on that loopback 0. So ISIS authentication MD5 ICT exam. Then enter interface gig 1 ISIS enable 1. Authentication is that. So let's see. Quit and display ISIS here. When you display ISIS peer, you can see here its peer is on a system ID of 0020.00200. That is the provider router. Then the state is up. Circuit ID you can see here. The state is up, and this is a level 2 router. Of course, okay. So meaning that ISIS is now running. The next thing we are going to do now is to see what is required in the next step after configuring ISIS. After configuring ISIS, you need to deploy OSPF in the data center. Deploy all routers in the data center in OSPF area 0. The address segment where the following interfaces reside must be advertised to the OSPF area 0. That is gig 101 of firewall 3. loopback 0 and gig 0/1 and /2 and /3 of data center gateway, loopback 0 gig 2 and gig 3 of leaf 1 and loopback 0 and gig 3 of leaf 2. So those are the requirements. So now we are proceeding to OSPF. So let's save our configurations here, so that in case we stop those devices, don't lose our work, and come and save it on the actual device. Start these routers that we stopped. So we want just to configure OSPF on this data center, where we are told that on firewall we are going to advertise this interface of gig 101, that is 30.1.1, and data center gateway we are going to advertise for gig 01, 02 and 03. This one we are going to advertise gig 2 and 3, and here we are only going to advertise gig 3 on into our OSPF. So let's stop these ones and work with the ones where we want to configure OSPF. So let's enter into our firewall and advertise the interface for the firewall that need to be advertised in the OSPF. So admin Huawei at 123. So OSPF here, process ID of 1. We said area, we are going to add everything to area 0, that is the backbone area. So the network that we are going to advertise to will be the network for gig 101, that is 30.1.1. So network of 30.1.1.0, because this one is /30. When you get its wildcard mask will be 0.0.0.3. So I believe you know how to get the wildcard mask. You just have to subtract 30 from 32 and know where 32 will pass to the last two bits, that is 1 plus 2, that gives you 3. So after advertising that network, we come to our gateway router here, and we configure OSPF process 1, and we said area here will be area 1, area 0, not 1. We are going to advertise the network that connects to the firewall. So first of all, we advertise the network for the loopback. So we need to know its loopback. So its quit and see the IP address of the loopback interface. Loopback 0. Display this. Its IP address is 1.1.1. Let's copy. Control C. So we've been told to advertise that network into the OSPF. So quit OSPF 1 area 0 network of Control V to paste that one. Then because this one is a /32, 32 minus 32 is 0. So our wildcard mask will be 0.0.0. You get that? Then we address the network where that connects to the firewall. So network of 30.1.1.0 with a mask of 0.0.0.3. We should see the LSS being exchanged. You can see here the neighbor state is now full. Also, we are going to configure the network that connects to leaf 1. So network of 30.1.2.0, mask of 0, wildcard mask of 0.0.0.3. Then the network that connect to leaf 2, that one will be network of 30.1.3.0, mask of 0.0.0.3. Then save your work. Say yes. So we've added the interfaces into our OSPF area 0. Then we come to leaf 1, say yes, OSPF interface loopback 0. IP display this to get its IP address. It is 12.12. We are going to copy that address, Control C, and quit. Enter OSPF view, OSPF 1 area view will be area 0. Advertise that network of the loopback, that is Control V, with a mask of 0.0.0.0. Then advertise it network that connects to the DC gateway. So network of 30.1.2.0, the mask of 0.0.0.3. It should be able to exchange LS with the DC router. And you see the neighbor state is now full. Then I'll address the network that connect to the web. So network of 172.168.1.0. This one is a /24, so its mask will be 0.0.0.255. 32 minus 24 will get 8, and 8 will, the total 8 bits when you add will give you to 55. So that is how you get its wildcard mask. So then Control Z to save. So yes, we are now on leaf 2. So interface loopback 0, display to pick the IP address. So it is 13.13. Control C, quit, and enter the OSPF view, OSPF 1, OSPF, not OSPF area, will be area 0. Advertise the network of Control V, the wildcard mask of 0.0.0.0. Then advertise the network that connects to router number, the DC, that is the network of 30.1.3.0, the wildcard mask of 0.0.0.3, because it is /30, and it should be able to exchange the LSS and establish a full state with the DC router. As you can see here, the state is now full, and also we are done. So save. So I want to start. Let's go back to our firewall and save the configuration. Control Z, save. Say yes. And we have to also save it on the device. And display OSPF routing. When you display OSPF routing here, you can see it has the route towards where 11, that is for itself, 3.1.13. So it should ping the loopback for leaf 1. So ping 12.12.12.12. it's able to ping. So meaning that OSPF has been established here. So and also on this interface we enabled ping service. So let's see as practical proceeds. So firewall 3 advertises a default route to the OSPF domain to direct the return traffic from the web server to the enterprise intranet. So the link between firewall 3 and 4 is disconnected. F3 must be able to stop advertising the default route so to prevent invalid traffic. So that's where we're going to configure BFD. Okay, so we're going to configure the default route domain to direct return traffic. So on firewall, we're going to advertise the default route. OSPF 1 default route advertise always. So we are advertising the default route on that firewall. Then we are also told that now when this interface is disconnected, the firewall should stop sending the OSPF default route. So wait, enable BFD. After enable BFD, we are going to enter interface. So interface gig1/0/1 OSPF BFD enable. So we enable a BFD on that interface so that this one ensure that when the interface goes up, it should stop sending the OSPF default route. So save, Control Z and save that configuration. So let's see from our directives here. Firewall 3 diverts traffic from the web server through the OSPF route this. Area 0. We are told that it has to advertise a network of 172.16.1.0, the mask of 0.0.0.255. Okay, that is what they are trying to say here. Firewall 3 diverts traffic to the web server through the OSPF route, this one. So firewall 3 advertises the default route to the OSPF domain to direct return traffic from the web server to the enterprise when the link. Okay. So that one is implemented. Now let's go to step number 5. On step number 5, configure IBGP peer relationship between loopback 0 of PE1 and loopback 0 of P, and between loopback 0 of PE2 and loopback 0 of P. Configure IBGP peer group on P and PE1 and PE2 to the peer group, add them. Configure P as the root reflector and P1 as the clients of the P. Configure extended gateway protocol relation between gig 3 of P1 and gig 3 of internet router. Use EBGP to advertise the loop 0 address of the internet router to its peer so that they direct up the uplink traffic. So that is what we are going to configure. Now here you need to understand there's a difference between IP version 4 BGP and also the VPN v4 BGP. So we are going to configure them differently. So in step number 5 here, this one implements IP version 4 BGP, but when it comes to MPLS here, where we're going to configure the VPN instances, we'll configure VPN version 4 BGP, where we're going to implement MP BGP. So let's begin here. In this lab, they didn't give us the autonomous system, so we are going to create our own autonomous system. Since they say router 1 and router 2 here, they are going to establish IBGP, this one and this one are going to establish IBGP, but now this one and this one is going to establish what is called a exterior border gateway protocol. So firewall also, we will assume that this firewall is on AS. So let's say this side is AS 1 SS300. That one is for the firewall. Then this internet is on AS 200. Then these other routers here are on AS 100. So we are going to establish now the IBG pair between this one and this one, and EBGP pair between this one. Then we are going to import the EBGP for the loopback into this our PE2 router. Let's stop the firewall and start those other devices. So let's start these devices on the internet. That is the one. So we are back on this router. We are going to configure BGP. First of all, let's see if we can ping the loopback. Ping loopback 2.2.2.2. It's able to ping that, after meaning that we are now able to establish now the BGP using the OSPF interfaces. So like the practical suggests that we are going to use create a peer relationship on the loopback interface of PE1 and loopback interface. So we are going to use the loopback interface, and you need to know how to configure loopback interface when establishing a peer relationship. So BGP here will be 100. Peer will be, we use the loopback for the peer will be 2.2.2.2. AS number here will be on the same AS number, that's 100. Then when you configure it on a loopback interface, you need to tell it to connect to the loopback interface. So peer 2.2.2.2 connect loopback 0, and you quit. Come to router number, that is the P router, say BGP 100, going to establish peer relationship with 1.1.1.1, and AS number here will be 100. Tell it connect to loopback 0, so peer 1.1.1.1 connect interface loopback 0. Then peer for PE2, so peer 3.3.3.3, that is for the loopback for PE2 is 3.3. S number here is on S100 because both the routers are on S number 100, that is PE1, P and PE2. Then connect to the interface. So you can see here the state has been has changed from open confirm to establish with the peer 1.1.1. So let's also enable it to connect to interface. So peer 3.3.3.3 connect interface loopback 0, and come to this one. PE1 is going to establish IBGP peer with P and EBGP peer with the internet. So enter BGP 100, peer here will be 2.2.2.2, AS number will be 100 for establishing IBGP peer. So connect with the loopback interface of peer 2.2.2.2, connect loopback interface 0. Should be able to enter the established state. let's see, display BGP peer. So it has established IBGP peer with, but now when you see here, you see the status is idle. So meaning it could be idle only when the interface is down. So let's check the interface for this gig 1. So create interface gig 0/0/1, display this has an IP address of 20.1.2. Create interface gig 0/0/1, display this. It also has a correctly connected interface. So display BGP peer. The status is now established. It connected with 3. It is established now. Initially it was idle again, maybe because the interface was down. So let's check again on that router. And the status is now established, meaning that the IBGP peer has been established. So quit, and we are on BGP 100. We want to establish eBGP peer with the router on the internet. So we are told here for PE1 and the internet, it should establish a BGP peer using the interface gig 0/0/3, not the loopback interface, as we can see here. Configure eBGP peer relationship between gig 0/3 of P1 and gig 0/3 of the internet. So it's not using loopback, it's using the actual interface. So peer, so interface, the IP address of those interfaces will be 20.4. Peer will be 20.1.4.2. The S number here will be 200. For a directly connected interface, you don't need to connect it to that interface. Only loopback, you have to configure that. And we come here and configure BGP 200. So then attach the net peer will be establish a peer relationship with the 20.1.4.1. The S number here will be 100. And you have to display BGP peer. That's still idle because the interface now maybe is still processing, so it will be established in a few seconds. Then you have been told now use eBGP to advertise the loopback 0 address of the interface router to its peer PE2. So we're going to advertise the loopback 0. So you see now here the status has now been confirmed. Now let's display again. Now the status is now established. Then we have been told to advertise the loopback IP address. So quit and see the loopback address interface loopback 0. Display this. Its address is 16.16. So copy that. Control C. Quit and go back to BGP 200. We're going to advertise that route, so enter IPv4 family unicast, then advertise the network of Control V, that network with the mask of 32. So you have touched that network, control Z, save, say yes. So we have attached that network into the BGP, display BGP routing table. When you display BGP routing table, you see now it has that route on it interface, because now it has been advertised by the peer router. So now can it ping that? Can it ping that? So ping, it's able to ping because it's directly connected to that, and it also has been added as eBGP peer. But these other ones, will they be able to now talk with that 16.16.16? Do they understand that route? So come here and try to ping. So ping, control V. It is not able to ping because it doesn't know where that route is. So we need to ensure that that route is reachable from this our router PE1. So display BGP routing table. We don't have anything on a BGP routing table. So what we're going to do, first of all, we are going to import the direct route on this PE. We are going to import the direct route. So import direct route. So after import the direct route, so let's see now if it is able to ping. Wait. So ping, control V. See, now it is now able to ping because it has imported that route. We've imported the direct route, that is 16.16, into our BGP route 100. So ping is not able to ping. Display BGP routing table. In the BGP routing table, we have 16, but on this, do we have it on this other BGP routing table? It doesn't have anything. So display BGP peer. It has established a peer with a .4. So to ensure that this route is reachable on this other router, we're going to import ISIS into the BGP to ensure that router PE1 should be able to see the route towards 16.16.16 for the loopback of internet router. So BGP 100 here. So import route ISIS1. So display, let's display routing table. When you display routing table, you can see here, still it doesn't understand where that is. So we come also on this router, enter BGP 100. So import ISIS1. Also come to this one, BGP import ISIS1. So let's see if this one route has now learned about .16. I can't find .16 yet. So let's see how we can ensure that that route is. We're going to configure the route reflector to see if that one will be able to allow router PE1 to see 16.16.16. So configure P as the route reflector and PE1 and PE2 as the clients, and configure the group IPGP group on P2B. So we're going to configure the route reflector on P1. So we are going as we have already established, so we are going to configure group name. Here we can give it group1, tell it internal. Then peer will be group1, peer will be group1. Then we tell it connect to the loop, connect to the interface loopback 0, interface loopback 0. Tell it connect to the interface loopback 0. After that, we are going to connect with the peer, that is router number PE1 and PE2. So peer 1.1.1.1, you attach to the group, and the group here was group1. Group name was group1. Peer 3.3.3.3, group here will be group name was group1. After that, I think we are going to tell it to reflect. So we tell it peer group name, configure it as the root reflector, so the RR. So here the group was group1, that is the name. Then tell it root reflect client, reflect root client. So this one is going to reflect the client, that is PE1 and PE2. Let's see if we can configure our cluster. Reflect cluster ID here will be 100. Okay, so after that one is done, I think we are through with the BGP. So display this. You can see them. The reflector has been enabled with the reflector ID of that. IS has been imported. So let's see if this one can find that route now. Good. Now you see here it has imported that route of 16. The next hop will be 20.1.4.2. That is the next hop will be .1.2 here. So that one has been enabled only after we configure the root reflector. So the root reflector has enabled us to reflect the roots on this PE2 to PE1. So PE1 will now be able to know what is going on on PE2, so that PE2 can tell it how to get to internet. It is not directly connected to PE1, but now P will act as will reflect the root of PE1 to PE2. So let's see if we can ping. So ping 16. Now if we ping, we can see now the packets are now able to go through successfully. So Control Z and save our configuration. So I think we are done with implementing the dynamic routing configuration for the public network. That is task number 7. In our next module, we are going to handle task number 8, that is MPLS VPN configuration. Up to this point, I hope you guys are enjoying the session. Remember to share your comment, tell me what I can improve on, and also subscribe if you haven't subscribed yet. If you're new to our channel, remember to subscribe to support our content. Thank you, and let's meet in our next module.